The Russian cement industry is a basic industry of the construction complex, which determines the state and development of the national economy as a whole. The South Ural Mining and Processing Company appointed the German company KHD Company, a worldwide leader in cement production technology, with the establishment of 2 complete cement lines of 1 million tons each. JSC Sibny ProAct Cement, one of the leading Russian project institutes, was selected for the execution of the detail engineering for the plant. The first kiln line, with a capacity of 1,200,000 tons of cement per year, started production in August 2010. The production start of the second line of the same capacity will be in 2012. The 110 6 kilovolt main transformer substation with a capacity of 50 megawatts supplies the power for the cement production. The clay crushing section is equipped with a roller crusher, which is fed by an apron conveyor. Nearby, there is an intermediary limestone store with discharging chutes and belt scales for the transport of limestone to the blending bed. A belt conveyor supplies the limestone into the blending bed store. This conveyor also feeds pre-dosed clay. In the raw material store, limestone and clay are stacked by means of a belt conveyor and a tripper. Reclaiming is performed by a bridge reclaimer, unloading the stack from its front end, allowing thus intensive mixing of stacked limestone and clay layers. The slag bending bed, located side by side, works according to the same principle of pre-homogenization. The raw grinding plant performs simultaneous grinding and drying of the limestone, blast furnace slag, and steelwork slag to such a state that these can be burnt as raw meal to clinker in the kiln plant. The raw materials intermediately stored in the bins and dosed by weigh belts according to a composition calculated by the Romex system software. This mixture is fed into a V-separator, where the fresh material is dried up. The raw meal is coarsely separated, and the press circulating material is dispersed from the roller press. Then a bucket elevator feeds the fresh and circulating material into the roller press, where raw material is produced under high pressure. Final fine separation is performed by a flow separator. An air slide system and a bucket elevator feed the raw meal into a homogenizing silo. In the homogenization silo, with its stock capacity for about 3 days, temporary fluctuations in the raw meal composition are corrected. This enables uniform burning of the raw material with minimum fuel consumption by the kiln line. The homogenized raw meal is fed by bucket elevator into the proportioning bin for kiln meal dosing. From there, it is discharged in a metered way and transported via an air slide system and by means of the bucket elevator to the preheater inlet. After the proportioning bin, that means before feeding into the preheater, raw samples are taken in short intervals, and their composition is determined in the laboratory. All that is done automatically. The feeding point for the raw material into the preheater is at the side of the riser duct of the second cyclone, which runs to both separating cyclones of the first cyclone stage. A rotary valve prevents cold false air from entering the kiln system. The preheater is a 5-stage single-flow cyclone preheater with a pyroclon R calciner. Final dewatering of the raw material and the essential part of the calcination process take place here. The necessary heat exchange takes place by a counterflow principle. That means raw meal passes downwards through the cyclone stages and through the calciner to the kiln inlet, whereas hot gases flow upwards coming from kiln and calciner. From the preheater, the material is passed through the kiln inlet into the pyro rapid kiln with 2 bearing points. In the rotary kiln, the core component of the plant, takes place the final calcination and sintering of the material to clinker. The process automation of the clinker production line is performed by means of the Product's PCS7 process control and monitoring system. The kiln fuel is natural gas, which is constantly and fully combusted by pyrojet burner. The pyrojet burner guarantees optimum flame optimizing under any operating conditions. The burner is fixed on a burner carriage. This carriage allows exact positioning of the burner. From the kiln discharge end, the hot clinker falls onto the pyrofloor cooler. In this ultra-modern cooler, the clinker is cooled down to a temperature of 70 degrees Celsius. The clinker is moved by cassettes on 6 mobile tracks, according to the walking floor principle, through the clinker cooler. During transportation, the clinker bed is swept by cooling air from the bottom to the top. The automatic control of the cooling air amount is performed by means of flow regulators. Dedusting of the air exhausted from the cooler takes place in an electrostatic precipitator. From the clinker cooler, the clinker is transported by a pan conveyor with deep-drawn pans to the store. The clinker is stored in a big 70,000-ton silo. A separate 3,000-ton silo is provided for off-grade clinker or for clinker shipment. The Novotroix Cement Factory produces Portland and slag cements. The gypsum, which regulates the cement binding agent setting time, is pre-crushed after feeding into an impact crusher, and then it is fed into the gypsum silo of the cement grinding plant. Cement grinding is performed in a big ball mill. The ball mill has 2 mill chambers. In the first chamber, clinker and additives are grinded by big diameter grinding balls, which create load impact. The pre-ground material passes through a diaphragm, and its finished grinding is performed in the longer second chamber by means of grinding balls of smaller diameter, which in turn perform mechanical abrasion. The bucket elevator and air slides feed the ground product into a dynamic separator. The central part of the separator is a rod cage rotor classifier in the centrifugal field, of which large particles that are not ground to the finished quality are separated from the ready cement. The cement is separated in 4 cyclones, and then it is transported to the cement silos. The cement is stored in a multi-chamber silo, where up to 6 sorts of cement can be stored at the same time. The loading of separate chambers is performed by means of an air slide system. There is an internal silo with 5 chambers and 1 external circular silo. Due to this innovative and highly compact design, costs and construction space are substantially saved. 2 points for truck cement loading and the railway bulk loading point can be fed from each chamber. A vibrating screen before each feeding unit prevents penetration of foreign bodies into the finished product. The truck drivers perform the loading process by themselves. Another connection from each chamber leads to the packing station, supplies a rotor packer, equipped with an impeller wheel and 8 filling nozzles for paper bag loading, with a loading capacity of 110 tons per hour. The bags can be loaded into open or covered trucks. For these purposes, 2 loaders are available. The third loader loads bags into closed railway wagons. It is also possible to fill so-called big bags with cement. In spite of all the counteractive factors, the cement industry today is considered to be gradually developing, and it has good development prospects. The new cement production of UUGPK Company in Novotroitsk will certainly become one of the most advanced Russian high-tech productions with quality and environmental safety that conform to the high European standards.